Alright, hey guys, this is 13.1, finding limits using tables and graphs. So we're going to talk about what even is a limit, and then looking at them on tables and graphs in this first section. So for all x approximately equal to c, and this little arrow means as x approaches c, with x not equal to c, the corresponding value of f of x is approximately equal to n. So that's what we mean by when x approaches c. So as x gets closer to c but remains unequal to c, the corresponding value gets closer to n. So we're going to first look at this on a table. So as x approaches 3, a 5x squared, and we can see we have the table here. So as we can see, we get closer to 3 this way and closer to 3 this way. It's getting closer to 45 and closer to 45. It's going up and going down. So therefore, my limit would be equal to 45. Okay. Now on this one, you actually have to type it into your calculator. So you can type this part into y equals. And so what I recommend you doing is then going to second table set. So that'd be second window. And then above that is the table set. And so then you can start your table at maybe 2 and go up by 0.01. So that way you can see how those steps are a little bit smaller. And so then when you do that, you can see that it's going to approach 4. And this one actually would be the same thing. You can keep the window or the table the same, and it's also going to approach 4. This one, make sure your calculator's in radian mode for this. You will want to start at 0, so you can scroll up and down around where you're approaching your limit, and the limit is going to equal 1 when you look at your table. Okay. So when we look down at these graphs, you can see that it's approaching from the left and the right. It's going to equal n. Now here, it doesn't actually equal n, the actual point. It's going to equal f of c, but the limit still equals n, so it's approaching from the left and from the right. So f of c, the point, is actually up here, but the limit still equals n. In this one, f of c is not defined, but again, the limit still equals n. Alright, so now we're going to look at some piecewise functions. Again, piecewise is just broken up into a couple different pieces, so I'm actually going to sketch these real quick by hand. So as x approaches 2, so 3x minus 2, 1, 2, 3 over 1, 1, 2, 3, 1, 2, 3 over 1. So when x is not equal to, and then when x equals 2, it equals 3. So 1, 2, and 3. So this is a situation like the second example back from right here, where the limit looks like this, but it's undefined. It's defined at a different point. Okay, so the limit is going to be this value right here. Okay, so what we're going to do to find that limit is you can just count up 1, 2, 3 over 1, so that's going to be at 4. Okay. Alright, so next one. So we have the limit as x approaches 0. So again, x when x is less than or equal to 0. Okay, and then we have it's going to look something like this. So we have something like that, and then when x is greater than 0, it's going to equal 1. So we have something that looks like this. Okay. Alright, now here we have a little bit of an issue because the limit from the left, so if we look at the left of 0 and the right of 0, they're going to be two different values. Okay, so here we're going to cue our inner mean girls, okay? And we're going to say the limit does not exist because the limit from the left does not equal the limit from the right. And we're going to get into this a little bit more later, but this is just a little bit of an introduction here, okay? The limit from the left does not equal the limit from the right. So if we're looking from the left, it would be 0. If we're looking from the right, it would be 1. 0 and 1 are not the same number, okay? All right, this one we're going to do a little bit later with algebraic techniques. But let's just actually go ahead and do it algebraically now. So you could go ahead and you could type this in graphically in your calculator, but we're going to do it algebraically to get some factoring practice in. Okay, so this is cubic and quartic, so we're going to actually have to factor by grouping. So if you remember factor by grouping, you're going to have to put them into 2 different pieces and factor out the GCF. So I end up with x squared minus 2. So x squared minus, x squared minus 2. And then 4. So x squared, let's see, hold on, let me go to that, that's not right. Okay, so I never factor by grouping, so x cubed, so we take the GCF out of that, so that's x squared, and then we're left with, okay, here we go, so x squared, so that would just be x minus 2, okay, here we go, plus 4x minus 2, there we go, okay. So then we get something that looks like, you see that this factor is the same, x minus 2, so x squared plus 4 is a factor, and x minus 2 is a factor. Now we can do the same thing on the bottom. Okay, what's the GCF there? It's x cubed, and then we're left with x minus 2, okay, and then plus 1. X minus 2, again we see x minus 2 as a factor, so I'm going to go ahead and write off to the side x squared plus 4 x minus 2 over x cubed plus 1 x minus 2. Okay, so what we end up getting is we can cross this out, this x minus 2. Okay, and we get x cubed, or x squared plus 4 over x cubed plus 1, okay, and the limit as x approaches 2, if you type that in your calculator, so this x squared plus 4, or we learn, we're going to learn that, again, this is a little bit of a preview, so kind of like foreshadowing, okay, that the limit as x approaches 2 algebraically is that you can just plug in 2. So you get 2 squared plus 4 over 2 to the third plus 1. So that's 8 over 9. So that's your limit. Okay, and so that is your introduction. Like I said, the last one is a little bit more algebra, which we'll get to in the next section. Okay, and that's all for that one.